Students, this is about the discussion of the grand test paper, today's grand test paper. As usual, now the time, it is around 3:46 p.m. Now let me see what are the questions that I can go with. This is related to some Stephen Salah, maybe. First question I can do. Second seems to be calculation based. Third, I can do. Fourth, hope gravitation, I think we can try. Fifth, AC comfortably we can do. Sixth, we can do comfortably. Seventh statement, undoubtedly we are supposed to do. Eighth is also a simple question, a repeated question. Ninth, formula based. If you are good at formula, okay. 10th is again a theory based question. 11th is formula based. 12th is also formula based. 13th, okay, we can try. Even though it is a rotation, we can try. 14th, modern physics, de Broglie, so we need to do 15 also we can. 16th, Young's double slit based, okay, we'll try, but later. Graph based, simple calorimeter based, we can do. Argon pipe, we can do. Matrix, we can do. It's a previous mains question, so we can do. Numericals, some calculation, some calculation, some calculation. Yeah. We cannot skip all questions. We can do. Right. Well, let us start dealing this paper. There is a rough selection from my side. Right. Two spherical bodies of same material having radius 1:3 ratio are placed in the same atmosphere. Temperature of the smaller body 1200 Kelvin and temperature of the bigger body is 300 Kelvin. If the energy radiated from the smaller body is E, the energy radiated from the bigger body is. Fine. In this particular question, see, they are asking rate. It depends on areas. If it is a black body, sigma A T to the power of 4, right? So therefore, it depends on the radius. So E1 by E2 is R1 square by R2 square. T1 power 4 by T2 power 4. Radius ratio is 1:3. So this is 1 by 9. And the temperatures ratio is 1 is 1200, 4 is 1, 4 power 4 by 1. So for clearly E2 is E1 times 9 by 256. So C is the correct option. We will work on to later. The potential energy of a 1 kg particle, potential as a function of x is given. First, equilibrium is what we need to find. Du by dx is equal to 0 means x cube minus x is equal to 0. X0 one option, x plus or minus 1 option. So very clearly, if I go with the d square u by dx square, I'll get 3x square minus 1. See, x is equal to 0, d square u by dx square negative, so unstable. Forget about that. You put x plus or minus 7, d square u by dx square positive. So therefore, plus or minus 1 concerns to stable equilibrium position. Minimum potential energy exists at this point. So what is U minimum? U minimum is very clearly 1 by 4 minus 1 by 2 minus 0.25. So Ke maximum plus U minimum is the total energy. That is 2 joules. So Ke max is equal to 2.25. 2.25 means it is again V square, mv square by 2 is 2.25. Mass fortunately 1, V is root 4.45, 4.50. It is root 9 by 2, 3 by root 2 meter per second. Right. Actually, it's a wrong choice to select this question. The if 3 point masses are released simultaneously to move under the influence of gravitational interaction, okay, speed of each particle when what is that they have given you moved through a distance. Here, my doubt, just have a doubt in this. My doubt is 3 point masses are released simultaneously. The initial distance of separation is not mentioned. The initial distance of separation must be A, otherwise you cannot do this question. So I have a doubt in this question. I'll do it later. Next, in an AC circuit, V and I are given. You can clearly see I is leading V by pi by 3. So cos phi is 61 by 2. Okay. Our power is ERMS, IRMS cos phi. Repeatedly, one question is coming from this last 3 or 4 grants. So 100 by root 2. IRMS is also 100 by root 2. Cos phi is 1 by 2. So overall, this is going to be 2500. And remember, this is milli, 10 power minus 3. So 2.5 watt is correct, right? Sixth question. A 1 microfarad capacitor is connected in the circuit shown below. The EMF of the cell is 2 volts, fine. Right, 2 volts. Even R1 and R2, okay, fine. They are steady state. First of all, remove this R1 line. What is the circuit in the steady state? 0.5 ohm, 2 volt, R2 is 1 ohm. Now, therefore, what is the current? Current is 2 by 1.5, 4 by 3 amps. So now what is the potential drop across the arrangement? Potential drop across the capacitor is 4 by 3 volt. Q is equal to CV. They are asking you charge. So therefore 1.33 microcoulomb. Right. Easy question. Only thing you need to identify is steady state. Ignore this line. And you need to find only the potential drop across this. That's all. Next, 7. Fortunately, theory question. A simple pendulum is taken to a planet of mass and radius. Mass of the planet is 4 times mass of Earth. Radius of the planet is 2 times radius of the Earth. G planet is Gm planet by R planet square. This is nothing but G times 4 times mass of Earth by 4 times radius of Earth square. This is nothing but G Earth. Are on the planet as well as on the Earth, G is the same. So automatically time period, length of the pendulum same means T is equal to 2 pi root L by G. So therefore, G is also same, L is same. So time period is the same. So in fact, G is same, so time period is the same. So therefore, for 7th question, the time period of pendulum remains the same is correct. Next, the mass of the pendulum remains unchanged is wrong. G is unchanged. That is the correct reason. So therefore, what I can say is mass of the pendulum remains unchanged is correct. Undoubtedly, at that time of the planet, statement is correct, but that is not the explanation. Right. Fortunately, good question. System shown in the figure is an equilibrium at rest. Area rest means just before cutting, the spring force on this is equal to the weight of the 2 blocks, 3 mg. Immediately after cutting, it will be only 2 mg and it will have an upward acceleration. What is that acceleration? Mg by 2m, g by 2 upwards. What about the lower block? Just you cut, it's a free falling body. It will have an acceleration g downwards. 2m block will have g by 2 acceleration upwards, and m mass block will have an acceleration g downwards. A is the correct answer. Next. The junction area of the solar cell is very narrow compared to a photodiode. Nothing like that. Nothing like that. You want correct statements. Consider the following statements. Right. You want a correct statement. Don't question me why and all that. You need to adjust according to the given situation. Solar cells are not connected with any external bias is an absolutely correct statement. LED is made of lightly doped PN junction diode. Mm, increase of forward current results in continue. No, there will be a saturation. LEDs have to be connected in forward biased for emission of light. Gunshot 2 and 5 are correct. 2 and 5 are correct. Right. Increase linearity, continuous increase of LED light intensity is not totally correct. 4, I am not clear. It's not totally correct. So therefore, okay, 2 and 5 are clearly correct. This is wrong. 1 is wrong. Pakka wrong. So therefore, options with 1 must be eliminated. So therefore, 2, 4 is also not correct. Right. 4 is also not correct. Why I am worried is I still know LED as per NCRT, it is a heavily doped PN junction diode. So LED is lightly doped. 3 is a wrong option. Wherever you have 3, root it out. Not only that, when the forward current of the diode is small, intensity of the light is small, undoubtedly, as per NCRT. As the forward current increases, the intensity of the light increases, undoubtedly, to some extent. But when you increase it, it reaches a maximum value. And what happens? If you are further increasing the forward current, what happens is the intensity of light decreases. It is not continuous increase of LED. Therefore, 4 is wrong. So 4 option is also wrong. So absolutely correct. So refer NCRT once again on this if you have any doubt. Next. A person cannot see clearly objects at a distance lesser than 100 centimeters. The power of the spectacles required to see clearly the object at 25 centimeters is. That's what you want, right? Okay, fine. Uh, in fact, it requires a convex lens for this purpose. Now, one more important point is object is placed at least distance of distinct vision. The image is expected to form at his nearest point, which is 100 centimeters. His near point is corrected. So therefore, 1 by minus 100 plus 1 by 25. There, this is means 1 by f. So finally, you will have 3 by 100. 1 by f. In diopters, it is 3 diopters. Right. A plano convex lens of focal length 30 centimeter had its plane surface silvered. An object is placed 40 centimeter from the lens on the convex side. Here you place. The distance of the image from the lens is. Are powers add kar bas. A plane part won't contribute any power. So total power is 2 by f here. So which means 1 by f equivalent is 2 by f, which means 1 by 15 centimeter, 1 by 15. Now, where you are placing the object? 40 centimeters. 1 by v plus 1 by minus 40 is minus 1 by 15. So, solving which, you will get v as minus 24 centimeters. Minus 24 means real image. It forms at 24 centimeters from the lens. It behaves like a concave mirror as a whole. Next, halo sphere of radius r and mass m is fully filled with non-viscous liquid of mass m. Non-viscous given, you should identify that. Means whatever the liquid inside behaves like a, a sphere without rolling. Water part is without rolling. Only shell part is with rolling. So therefore, what is the total kinetic energy? Total kinetic energy is Ke rolling of shell plus Ke translational of shell plus Ke translational of the water sphere. So this part together you can write shell and 2 by 3 normally. About total part will be 1 plus 2 by 3, 5 by 3 mv square plus a half mv square because the liquid is also of same mass. By the way, kinetic energy is nowhere matching, so both are wrong. The angular momentum we will take. Angular momentum is angular momentum of the rolling shell plus translating water. Rolling shell, same 5 by 3 MVR plus translational of water MVR. This will become 8 by 3 MVR. This you need to identify. This is separate, that is separate. Okay, easy question. Fortunately, non-viscous. Right. 14th question. An electromagnetic wave of wavelength lambda is incident on a photosensitive surface of negligible work function. If m is the mass of the photoelectron emitted from the surface, has de Broglie wavelength lambda, or what is that they want is hc by lambda is the energy, no work function. This you can write it as p square by 2m. Wherever momentum you have now, you can write it as 2mhc by lambda, right? P is nothing but h by lambda de Broglie, which you can write it as 2mhc by lambda. Squaring on both the sides gives you 2mhc by lambda. H cancel. So lambda is 2mc by h lambda de Broglie square. You have C as the option. Array, you must have patience to close this question. Stepwise, carefully, if you can apply, you can make it. 15th, a current I flows through a thin wire as shown in the figure. There exists an external, okay, fine, torque, or MB, torque. Magnetic moment means current into area. Only skill lies is in identifying the area. I can see, what I can see here is, see carefully, what I can see here is square, square plus half circle. I repeat, square, square plus half circle. So therefore, area part clearly is, area is 2 times square of side 2a, 4a square plus half circle. Circle is of radius a, 5a square by 2. Right. Okay. Next, torque is MB. Current into area into B. I into B into A square into 8 plus pi by 2. 8 plus pi by 2 A square BI. A is correct option. Maximum intensity in Young's double-slit experiment is I naught given. Distance between the slits D is equal to 5 lambda. Okay, what will be the intensity in one front of what normal formula y, I mean, in front of means y location of that is 2.5 lambda because total is 5 lambda. D by 2 kada. Next, D by 2. Okay. By the way, what is d sin theta in this case? D sin theta is the path difference. D into y is 5 lambda by 2, and this is here, this is 5 lambda d by 2, and this is a 10d. So very small angle then. Almost tan theta is the same as sin theta, and this is 1 by 20. D times 1 by 20 is delta x. Path difference is 5 lambda by 20, lambda by 4. Equivalent phase difference is pi by 2. Okay, pi by 2 is the phase difference. So I is I1 plus I2 plus 2 root I1 I2 cos pi. Entire term vanishes. Are full intensity and a constructive intensity is I0. Normally our formula for I0. I0 by 4. Each is I0 by 4. I0 by 2. I0 by 2 is the answer. Right. Next. 17th question. A given mass m is a hypothetical solid supplied with heat continuously at a constant rate and a graph is shown. Okay, fine. This is the space of, this is the space for melting or boiling. This is melting, this is boiling, latent heat part. L part is this. Slope of these two lines gives specific heats. Okay. Clearly, more time, so more heat is taken. So L fusion is greater than LV because the length of this line is more when compared to the length of this line. More heat is taking. The meaning is more heat is taken. ఎక్కువ time తీసుకుంటుంది. Next. Clearly, the slope of this line is more than the slope of this line. So which means yes, a specific heats of liquid and solid. Yes, L is greater than specific heat of liquid is greater than specific heat of liquid is greater than. So for this part, what you will do is you are taking some heat Q. This is equal to ms, normally delta T. Now here dq by dt is delta T by delta T. Now which means this product, remember you are giving it a constant rate. dq by dt is constant. Mass anyway is constant. So S into slope of the line is a constant. Slope of line is a constant. Here this is more slope. But S is less. So therefore SL must be less than SS. So therefore C is absolutely correct answer. Remember, if you don't know this, you are out. Next, 18th question. An open organ pipe vibrates with a tuning for frequency given successive notes. Which means lambda by 2 is given as 46 minus 16 centimeters, 10 power minus 2. So clearly, lambda is 60 centimeters. Okay, 60 into 10 power minus 2 meters. So therefore, velocity is frequency times wavelength. 500 into 60 into 10 power minus 2, which is 300 meter per second. So 300 meter per second is absolutely correct answer. 18th question, 300 meter per second must be the answer. Right. Go for 19th question. Ultraviolet rays for sterilization. Corona time, everyone knows this. Infrared rays, X-rays is for study of crystal structure. S1, P3, P3, S1. Okay, this is the only option. I don't even require to check. In the given circuit, the sliding contact is pulled outwards such that the electric current in the circuit decreases at the rate of 1. No, which means you can take this as the inductor will behave like this, L di by dt. And some resistance. Already this is a 10 volts. L di by dt means 2 into 1, 2 volt. At that instant, resistance is 4 ohms. So what is going to be the current? Current is 12 by 4, 3 amps. Right. Hold on. Hold on. Easy questions first. Okay. In the circuit indicated, find the current through both the batteries, I1 and I2. Right. Arya, you reduce this properly. Totally reduce this properly. This is 12 volts, 10 ohms, 20 ohms, 6 and 2, 1.5 ohm. This totally 2 ohm, 2 plus 3, 5 ohm. That's the circuit, 6 volts. Now we know how to handle such circuits. I am finding out the current through here. And the formula for this is E1 R2 minus, because they are oppositely polarized. E1 R2 minus E2 R1 by R1 plus R2 by capital R plus R1 R2 by R1 plus R2. You know this relation. Now the problem is 12 into 5 is the same as 6 into 10, which means no current through this 20 ohms. This is the first factor that you need to identify. No current. Means whatever the current that flows through this branch, periphery only, like this only. Okay, fine. What is the current in that case? Both batteries are aiding each other. 12 plus 6. And total resistance is 15. 18 by 15. Uh, 6 by 5. In fact, it is 1.2 amps. So each battery, the current is 1.5 amps. 1.5, or 1 minute, 1.2 amps. 1.2 plus 1.2 is 2.4 amps. And which is 2.4 amps. So what they want is 5x by 6 means 5 by 6 times of 2.4. 0.4. 2. The answer is a 2 for this. Absolutely correct. The least count of a screw gauge is 0.01 mm. Area least count is pitch of the screw by number of circular scale divisions. You said pitch is increased by 50. Earlier 100, now it becomes 150. Earlier circular scale divisions 100, now reduced by 75, 25 means it becomes 75. So least count becomes 2 times of the previous value. Previously, you have given this much, 2 into 0.01 mm. This can be written as 20 into, 20 into 10 power minus 3 mm. Correct. Fine, fine. Good. My flow is absolutely fine. So I need to consider the balance questions. Let us go for the second question. In the second question, electron is made to enter symmetrically between two parallel and equally but oppositely charged metal plates, each of 5 centimeters length. Electron emerges out of the field of this region with a horizontal component. Okay, fine. With this data, what I can, for example, if you are assuming these are the plates, and this is how you are projected, and this is how the electron arrives. This is horizontal component, this is vertical component. As per the given data, this will become 1 by 2 into 10 power 9. Just keep it like that. The next part, Vy is what you want. Vy is AT. A is EE by M T. So EE by M into T. EE means 1.6 into 10 power minus 19. 1.6 into 10 power 19. And you said 9.1 volt per meter. 9.1 into 10 power 2 volt per centimeter kada. 10 power 2 volt per centimeter. And 1 by centimeter meters marchinappudu 1 by 100th of a meter. So 9.1 into 10 power 2 by mass. 9.1 into 10 to the power of minus 31 into time. 5 into 10 to the power of 10. Actually, when I solved this, I got 8 into 10 to the power of 4. but no such option is given. But otherwise also, what is that I can notice is this is this is the possibly correct answer. I got 8 into 10 to the power of 4. But multiplication factor is missing in every option. Right. Are obviously when 10 power 8 meter per second is that component, this should be at least of that nearest range at least. Um, Maybe they would have done this as 9.1 volt per meter. Then 8 meter per second is correct. Right. And fourth question, as per my knowledge, some data is missing. Initial distance of separation is missing. Suppose initially they are all separated by A, then I can write it as 3gm square by A is the initial potential energy. And as per your data, A by 2 root 3 means their initial distance of separation becomes A by, initially A, finally A by 2. Then that will become 3gm square by A by 2, and that is kinetic energy part into 3. Only then we will get this answer. But where did they mention that the initial distance of separation is A? That is my doubt. So I'm assuming B is the answer for this. So mostly I have done all the questions, and only numerical part is left. 21st question, numerical part with slightly calculation is there. Slightly calculation is there. What is that calculation is? You need to understand what is given. Y is equal to 2 by 3 x minus 1 all to the power of 3 by 2. 3 by 2. Okay. So that is y, and you take dy. Dy you will get as 2 by 3 into 3 by 2 into x minus 1 whole power 1 by 2 into dx. So therefore, dy square plus dx square, if I take, it will come as root x dx. Sir, why all this? Because this is root x dx. Because we want the mass of this element. The mass of that element is lambda root x dx. Why I require? Because xcm is dmx by integral dm. By solving which, you will get the answer as 3 into 31 by 35. So 3 is the answer for this. Only thing that you need to identify is how to use this data. Right. 22. It's a more or less a simple calculation, actually. Not much is involved, actually. Only thing that you need to understand is equation of continuity. A1, V1 is equal to A2, V2. Here, ratios of radius is 2:1. So, therefore, 4 times V1 is equal to V2. That is one relation. From here to here, if you apply Bernoulli's equation, rho V1 square by 2 is equal to rho V2 square by 2 minus rho GH. Loss in the pressure path. By rho cancel, H they have given, just substitute. You apply in the place of V2 for V1. You will get the expression for V1 and V2. You will get V1 as 1 by 5 meter per second and V2 as 4 by 5 meter per second. But no one is asking this. Volume flow is AV1, which means pi 3 into 10 power minus 3 square into V1 square, 1 by 25. Fortunately, in terms of pi only, they have asked. See, the only thing is conversion of units is important in this question. By doing which, you will get the answer. If anyone goes wrong, calculation part, this is one such question in this paper. Next, 23. Nuclear reactor generates power by fission of U90 to 235 into fragments, 2 fragments. Fine, no issues. See, here also, my observation is that the calculation part is valid. Very important calculation part. If you are good at calculation, you are done. So what I have done is that 7.2 into 235 is one energy. And final energy, 1 minute. final energy is 8.2 into 2 into 116 minus 7.2 into 1 into uranium kada 235. You need to find this difference. You will get nearly this as a 210.4. I've done this. Now, out of which 2 gamma rays, each of 5.2 is given out. So remove 10.4 from this. So 200 is available in the form of K of the fragments. And that is the usable energy released per fission. So 200 is the answer for this. So I hope I have done all the questions. Remember, except 2 or 3, rest all, even calculation is not also involved. A ninth question you see, ninth question is also there, which is an easy question as per my knowledge. Ninth question, we should carefully define. This won't contribute any field, undoubtedly. Any field contributions, you have 1 year, 2 year, 3 year, right? So let us take that very carefully, one after the other. By taking careful observations, I am taking one after the other. Please remember, I am now first taking about this. That will contribute in the K cap direction. 1/4, I mean quarter circle kada. Mu naught I by 2 times R to R in K cap direction. Now again straight line. Mu naught by 4 pi I by R. Which direction? Upwards. Means Jx J cap. And one more again in positive Z direction. 1 by 4 mu naught by 2 I by R K cap. So J cap, K cap term. So you'll get option as a D for this. Remember, this won't contribute any field because it is passing through that point. So I have done all the questions. Basically, it's an easy paper. 85-90 is nothing in this. Right.